Bismillahirrahmanirrahim. The presentation of Safa BESRA about synthesis and characterization of zinc oxide and zinc sulfide pure thin films using chemical pyrolysis technique. Introduction. The zinc sulfide and zinc oxide are promising materials for the use in various application devices such as gas sensors, solar cells, photocatalysts for the degradation of organic dyes, and photovoltaic. The pyrolysis process is one of the simplest and cost-effective thin films elaboration method in terms of layer quality. The focus of this study is the elaboration and characterization of pure zinc sulfide and oxide thin films prepared by pyrolysis chemical method on glass substrates. The physical properties of this film were studied according to the experimental conditions. We characterized our films by X-ray diffraction and infrared spectroscopy and scanning electron microscopy. Experimental details. The glass substrates were cleaned with acetone, methanol, and distilled water. The supply solution was prepared from zinc sulfate ZnSO4 as a precursor with molar concentration 0.2 molarity dissolved in 50 ml of double distilled water with magnetic stirring during 25 minutes to obtain a clear and homogeneous solution. The solution was then directly sprayed onto heated glass substrate using two various spray times, 1 minute and 40 seconds and 2 minutes and 40 seconds to make the ZNS thin films adhere. Once the spraying process was completed, we let the samples cool until room temperature. The structural study was determined by X-ray diffraction using diffractometer with a copper anode, Fourier transform, infrared spectroscopy (FTIR). The film's morphology was analyzed by scanning electron microscopy. Results and discussion. In figures, we have reported the XRD diagrams obtained in the film's products. In the films produced from the solution studied, as we can see, the deposition time of thin layers influence on the crystal structure of films. A typical XRD pattern of the ZNS film growth by pyrolysis at 430 degrees C on glass substrate. The diffraction pattern of this film revealed a Schwarzschild crystal structure ZNS with a strong preferred orientation along the hexagonal 002 ZNS plane direction. The average crystallite size calculated by the Scherer equation from XRD pattern is 63 nanometers. The infrared spectra of zinc sulfide comprises 7 in the 500 to 4500 range. The FTIR spectrum presents two types of bands, either broad and intense bands or faint peaks of less intensity. Two observation bands are of the first type. The band located at 543 is assigned to the straining vibration of the band of zinc and sulfide band. In addition, the presence of another band is observed and the rest of the band are identical in both spectra. In parallel, during the preparation of the zinc sulfide thin films, we prepare the zinc oxide thin layers by separate pyrolysis from two different sources of zinc sulfate and zinc nitrate, with 0.1 molarity. The time of deposition was 10 minutes at substrate temperature 350 degrees C on air atmosphere. The structural analysis of our thin films were performed by X-ray diffraction, the presented pattern, and the morphological properties were studied by the scanning electron microscopy. Scanning electron microscopy analysis revealed that the films have a rough appearance, suggesting that the films prepared by spray can be used for photovoltaic application. Conclusion. The results of this study revealed that the zinc oxide and zinc sulfide films have been successfully prepared by separate pyrolysis method. The microstructural of zinc oxide and zinc sulfide were characterized by XRD pattern and scanning electron microscopy images. The XRD pattern of these exhibits excellent crystalline structure with the preferential orientation of 002. The scanning electron microscopy images indicate that the films have a rough appearance, which suggests that the prepared films can be used for photovoltaic application. Otherwise, we observed that the zinc oxide zinc sulfide film prepared by spray, whatever the starting solution, are transparent and have a rough appearance on the surface, which suggests that our elaboration method makes it possible to obtain ZNS film, which find their application in photovoltaic conversion by integrating them as a front layer in solar cells. At last, thank you for listening.